Good day, grade 7 learners, and welcome back to the new episode of Learning, where learning becomes easy once we explore. So hang on tight and let us discover the beauty of Science 7. Make sure that you have the following before we start: paper, pen, and self-learning module. Did you call somebody today using your smartphone? Did you listen to your favorite radio station this morning? Have you tried cooking your food with a microwave oven? Did you know that all these human activities, calling someone using your smartphone, tuning to your favorite radio station, cooking food in a microwave oven, they all have one in common. They all have electromagnetic waves or EM waves. We have learned in our previous lesson in science that wave is a temporary disturbance that transfers energy from one place to another. There are two important ways on how energy transfer, either by means of electromagnetic waves or mechanical waves. The electromagnetic spectrum is composed of EM waves. These are the waves that are created as the result of radiation between electric field and magnetic field. In other words, EM waves are composed of oscillating magnetic and electric field. This is why they are called electromagnetic waves. The EM waves are perpendicular to each other and they are perpendicular to the propagation of the wave. The electromagnetic spectrum is ordered or arranged by its frequency. And electromagnetic waves can travel through air, solid material, or even vacuum. It does not need the medium to propagate or travel from one place to another. Electromagnetic waves can either travel in a vacuum in the outer space. As we can see the electromagnetic spectrum, we can find out that it consists of the different characteristics. Now, let us discuss the different characteristics of an electromagnetic spectrum. Amplitude. It is usually referred to the capital letter A, the height of a wave usually measured in meters. Remember, the greater the amplitude of the wave, then the more energy it is carrying. Another wave's characteristics is wavelength, in symbol lambda. It refers to the distance between two consecutive crests or throws, and usually measured in meters. Next is frequency, which is the number of waves passing a point in a certain time. We normally use a time of 1 second, so it gives us the frequency unit hertz, since the hertz is equally to 1 wave per second. Let's have practice exercise. Study these two waves. Which wave have higher frequency? Wave B has higher frequency than wave A. Which wave has longer wavelength? Wave A has longer wavelength than wave B. Remember also that all electromagnetic wave travels at the same speed, which is about 3 × 10⁸ meter per second through a vacuum. As you further understand our lesson in EM waves, please take note on the following wave equation. Electromagnetic waves obey the following formula. This triangulation method helps us understand the wave equation, which is wave speed is equal to frequency multiplied by wavelength. And now, let us try to solve a problem using wave equation. An EM wave has a wavelength of 4.0 meter in a vacuum space. What is the frequency of the EM wave? First, let us identify the given. The given are wavelength is equal to 4.0 meter, and the speed of EM waves in a vacuum is 3 × 10⁸ meter per second. We are looking for the frequency of the EM waves. For the equation, we will using the equation V is equal to F multiplied by wavelength. First, we need to derive the equation needed and substitute to the given value. The derived equation is F is equal to speed of EM waves divided by wavelength. The answer is 75 million hertz or 75 megahertz. There are different types of EM waves, such as radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. These EM waves can be split into range of frequency or wavelength. That is why it is known as electromagnetic spectrum. And that's it for today. And now, you are going to draw an electromagnetic spectrum in your bond paper. You are going to draw an example also of an electromagnetic spectrum based on their frequency. And that's it for today. I hope that you have fun learning and discovering about electromagnetic waves. See you again for the next episode of learning.